We would like to implement a robot arm that can operate inside the space station or spacecraft to grab objects with zero gravity. If any object floats in the air, the robot arm will grab it and put it in the storage or the shelf, or hand over to the hands of a spaceman. It could be food tubes, utensils, or other instruments. It might help both in daily life and scientific work. As we know, there is an enormous number of experiments conducted every day on the space station, such as chemical and biological tests. Implementing the robot arm in those experiments could help to achieve better precision and avoid negative impact on health of the astronauts. A robot arm could make cosmonauts' life easier. For our environment, we took the reference from the astronauts' real daily life routine. Spacemen consume food from the specific tubes and packages to avoid dispersion of substances in zero-gravity environment. We specifically selected certain objects and downloaded from the internet and scaled up them using software by ourselves. Of course, some of the objects were created and edited in SolidWorks as there were no alternatives. The objects include packet, tubes, utensils, jar, and etc. We also have a pair of shelves and a fridge as a common interior of the space station, which can be used to store the objects. The cutter robot is a 3 degrees of freedom robot arm which is used in the simulation in our project. The programming of the robot is done by Python codes, introduced in the lab classes and enhanced by our team. In the following environment, the robot has certain constraints and an end effector, which is used to grab different objects. As the station's interior is very compact, the motion should be as precise as possible and moderately paced to avoid collisions at the same time.
Now we are going to conduct testing on 3 cases with 3 objects respectively. For spoon, it is an important item in space to allow astronauts to eat just like on the Earth. It is delicate and small, which is an ideal object to be removed by the robot. This is the result with a 14-second blended linear trajectory. In this trajectory, the inputs and outputs are as follows. As you can see, the robot grabs the floating spoon and puts it in the tools table. For packets, they are common containers for food, and the interior is usually treated with vacuum, so that the packaged food is very much flat and collapsed, giving packets the shape of slim but wide. This is the result with a 8-second cubic trajectory. In this trajectory, the inputs and outputs are as follows. Let's watch the footage again with another viewing angle. For tube, it is also a common container for different items in the space, such as experiment substances, batteries, and lab utensils. This is the result with a 11-second quintet trajectory. In this trajectory, inputs and outputs are as follows. Let's watch the footage again with another viewing angle. Due to the nature of our resources, we can only display intended movement with designated trajectories. In the future, we believe such concepts can be further developed in the intelligent path. We expect such intelligent robots could dynamically locate the floating and moving objects in space, and also design suitable trajectories for the scenarios. Thank you for watching.